right, so we have section 4.9, quadratic systems. And our objectives are to solve and graph systems of lines in quadratic equations, and to solve and graph systems of quadratic inequalities. All right, so when we talk about systems, we have to remember we've already done this with lines. So when we had a system of equations and they were linear, and it's two or more lines, and we're solving for where those lines intersect. So the possibilities were the two lines could not intersect at all. We could have no solution. The two lines could intersect, and then we have one solution. Or the two lines simplify to the exact same equation, and they overlap completely, which means we have an infinite, that's an infinity sign, an infinite number of solutions. Right? So when we were, this is just a reminder of what we've already done. You don't need to write all this down. This is just checking back on things that we have completed already. So today, we're going to start doing systems that involve quadratics. Quadratic means the shape is what? It's a parabola. So now we're going to have some parabolas. So the possibilities when we deal with parabolas in lines, this one I would put in your notes, is we can have a parabola and a line that intersect at two places, meaning that we have two solutions. A parabola and a line that intersect at one point, and that point would have to be the vertex to get one solution. Or again, we could still have a parabola and a line that never intersect. So that's when we have a parabola and a line. And I'll make some sketches down here for when we have two parabolas. So when our system consists of two parabolas, here are the sketches of what it would look like if we had two solutions, one solution, or no solution. Okay, we're looking for the places they intersect. And when they intersect, we need to remember their y values are the same. So at the intersection, y values are equal. And x values, but the important thing is y values are equal. All right, so now we're going to talk about how to solve these systems. And first we'll look at how to solve them graphically with our calculators. So we have an example. This is a linear quadratic system. And we want to solve it by graphing. So what you want to do is in y1, put in negative x squared plus 5x plus 6. If you don't have a calculator, there's a few in my crate. Get up and get one, please. These are those helpful things that you really should know how to do to check your answers on a test or quiz. In y2, let's put in x plus 6. And our y-intercept is 6 here. This is a parabola that opens down. Let's just start with zoom 6 to look at the graph. Okay, so we have our first equation in y1 and our second equation in y2, and I said let's start with zoom 6, a standard window just to see. There's our parabola. And there is our line. Now you can see we're kind of short on space at the top of the screen. So we need to go to window, and what should I change? X min, X max, Y min, or Y max?
Just choose them all.
We don't need to change them all.
Y max.
Just the y max. We need to go further up. So let's change our y max to, let's make it 50, just to be on the safe side. And let's change our interval to 5, y scale. And now let's graph that. Here we go. Easier to see the intersection. Okay. Now, just like when we found x-intercepts, there are 2 of them in this case for us to find. Yeah, do your calculator. Okay, go up and get one. And unplug your ear, please. All right, and that is on the video, just so you know. Okay, so we're going to do second calc intersect. So we want to do second and the trace button to get to calculate, and go down to intersect, which is number 5. We're going to have to do this twice because there are 2 intersections. Julia, there might be another one. We'll get one.
Yeah, can you repeat that?
Yes, second, and then the trace button is calculate, and then I pick intersect. So it's second calc intersect. And just like when we found the x-intercepts, the zeros, we have to give it a left bound and a right bound immediately around the intersection. And we want to use the left arrow to move just to the left of the intersection. Okay? Move the left arrow, so I'm just to the left of one of the intersections. Hit enter. It now asks for a second curve. Move it just a little on the right. The second curve, notice we're on the other equation. Hit enter again. Now it's saying yes. Hit enter one more time. So our intersection, now what does it mean when your calculator says 1.11 times 10 to the negative 15? It's your calculator trying to say what? 0. So this is 0, and what's the y value? 6. So our first intersection, our first solution to the system is 0, 6. So we want to write that. Based on our calculator, we get 0, 6. And now let's go back and get the other one. So we want to do second calc intersect again. 2 seconds. I want to hit enter on that. But now I want to get over and move my cursor to the other intersection. Just use the right arrow to move over. And really, we just want to sit right on top of the intersection where they're crossing. I said move to the left and right, but I forgot. We don't really need that for the intersection. We just need to sit on top of the intersection point. It's saying, is that the first curve? Is that equation our first curve? We hit enter. We're sitting right on it. It says second curve. We hit enter. And now it says yes. We hit enter one more time. And what is that point? 410. So our second intersection point is 410. So the question said, which numbers are y values of the solutions to the system of equations? So what should it be? 6 and 10, the y values. Okay? So that's how we can do this graphically with our calculator. But, you know, we'll have to do it by hand. Questions on the calculator part? Okay. All right, let's move on. Okay. Now solving a linear quadratic system using substitution. Well, what is the substitution method with lines? What do we do? Help me. What do we do when we do substitution? Dylan, do you remember?
You plug in this letter for each, and if it says x equals something, you put that in for x.
Okay. You solve for one variable and plug into the other equation. Solve for one variable. And then you plug that into the other equation. Well, they have made it very easy for us in this problem. what is the solution to the system of equations? They have y equals x plus 3 and y equals x negative x squared minus x plus 6. They've already solved for one variable. So all we need to do is plug in x plus 3 for what? For y in the first equation. All right, so that means I have x plus 3 equals negative x squared minus x plus 6. And then we have to solve this. Tell me what you want to do. It's a quadratic. What are our methods for solving quadratic?
Quadratic formula.
Quadratic formula is one, and we have to get everything on one side for that. Factoring is another. We have to get everything on one side for that. Completing the square. I would always say completing the square is your last option. All right, so let's get everything on one side of the equation. We're going to move the x. How do I move the x over? Subtract x. And subtract 3. And now we have, no, 0 equals negative x squared, then what? Minus 2x, and then plus 3. So, what method do you want to use? I always check to see the factors first, because factoring tends to be the easiest, so let's just check that. And the factor, I always pull out the negative one first, so I'm going to say factor with a question mark to see if it factors easily. 0 equals negative 1 times, that becomes x squared, then what?
2.
Plus 2x, and minus 3. So we want factors of negative 3 that add to positive 2. 3 and 1, which one has to be positive? Yes. So it's 3 and negative 1. And the coefficient in front of my x squared is 1, so those are my factors. So we get negative 1 times what? X plus 3 times, right. And we can only do that shortcut because the coefficient in front of the x squared is 1. Otherwise, we'd have to do the grouping and all of that. All right, now what do I do? That's not the answer yet. We're solving for x. Set them equal to 0. We take each of our factors and set equal to 0 with a 0 product property. Well, negative 1 equals 0. That can never happen. X plus 3 equals 0. And x minus 1 equals 0. Now we solve these. Here I get what? 3. Not 3, but 3. X equals negative 3. And x equals 1. So, this line and parabola intersect at 2 places at x equals 1 and x equals negative 3. And we are done. Okay, what is the solution to the system of equations? We found the x. How do I find the y? Yep, plug back into the easier equation. So we're going to plug into y equals x plus 3. So we get y equals negative 3 plus 3, which is 0. And y equals 1 plus 3, which is 4. So what are my 2 points of intersection? Negative 3, comma, 0. And 1, comma, 4. Questions on what we did there? Exactly the same process as solving a system of linear equations with substitution. But now we have to use our methods for solving a quadratic. Okay, questions there? All right. Let's see what's next. Okay, So, using substitution, you're doing this one at your desk. It looks like it will be a more challenging problem, but it works out very nicely. So at your desk, we have y equals negative x squared minus x plus 12, and y equals x squared plus 7x plus 12. You're using substitution. So solve that now, please. So that I have 0 equals 2x squared plus 8x. Well, that's a much easier problem to solve. Factoring is still going to be your easiest way, but if you prefer quadratic formula, you can do that. If you prefer completing the square, you can do that. But factoring is definitely the easiest way to go on this one. You should always try factoring first. What can I factor out of these two? 2x. Leaving me with? Plus 4. So those are my two factors. So I set them equal to 0 using the zero product property. 2x equals 0, and x plus 4 equals 0. So we get x equals 0, and x equals negative 4. We subtract the 4 over. All right, those are my x's. How do I get my y? Yep, back into one of the original two. So I'll do the one with the positive, x squared plus 7x plus 12. And when we plug in 0, what do we get? Yep. So one of our intersections is 0, 12. Do be careful plugging in a negative 4 in your calculator when you're doing your work. Keep your negative in parentheses. Negative 4 squared plus 7 times negative 4 plus 12. So this is actually positive 16 minus 28 plus 12. 16 minus 28 is what?
12.
Negative 12. Plus 12 gives us 0. So then we get negative 4, 0 as our second solution. Again, we have two intersections. Okay? On some of them, you will not be able to factor, and you'll have to do either quadratic formula or completing the quiz. Any questions on that one? Okay. Almost done. All right. And I just want to talk about when we have quadratic inequalities. We solve systems of inequalities by graphing and shading. The same thing happens with parabolas. So we have a parabola, we have two parabolas here. You would have to graph this parabola, and we want to know where y is less than that. So remember, we picked a test point, a nice easy test point. You plug it in to see if it's true, and you shade the true side. The true side with the parabola will either be inside the parabola or outside the parabola. And we need to remember with less than, it is a dashed parabola and not a solid. And then we graph the second one, x squared minus 2, which is the red one that we have here. We take a test point and find out if we shade inside or outside the parabola. In this case, we shade inside. So our solution area is where the shading overlaps. So our solution area is right in here. Okay, so we do need to be able to graph our parabolas the way that you did on the 4 graph lab. Okay? And that's all we've got. All right, let's take a look at our assignment sheet. These can be a little lengthy. So we'll see if we are shortening that.